This video is about factoring special cases. So there are distinct trinomials or binomials that come out from doing our multiplication of two binomials that have a specific pattern that we can look for. So let's look at some examples. So all of these will say factor. And the first one is x squared minus 9. Now notice there is no middle term, and that's what makes it special. Most factorings have a trinomial. This one has a binomial. And so the middle term is 0. So realistically, this is x squared plus 0x minus 9, if we want to look at it that way. So let's take a look. Our first term is x squared, so that's x times x. And then we have to think of factors of 9, so things that multiply to 9. So we have 1 and 9, and we have 3 and 3. And we have to think which ones of those is going to add or subtract to 0. So if I were to subtract them, would I get 0? And so we have to think, well, it's got to be the same number. If I have the same number and I subtract that amount, it's going to give us 0. So we're going to try the 3 and the 3. We make 1 plus and 1 minus. Now, how can I tell that I did this correctly? Check your outers and inners. So we have x times a negative 3, and we have 3 times x. So here we get negative 3x, and on this one we get 3x, and so negative 3x plus 3x equals 0. So this is our final answer. So same factors, but one is plus and one is minus. Next example, again we're going to factor 4a squared minus 25. Very similar to the last one, we don't have a middle term. So in order to get that, we need the same factor twice. So we have to think what number times itself gives me 4a. And so that would be 2a times 2a. And then what number times itself will give me 25, and that's 5 and 5. And we make one positive and one negative. Again, you can check your outers and inners on this one. So we have 2a times a negative 5. And we have 5 times 2a. So we have negative 10a plus 10a would give me that 0 in the middle. Next example, we want to factor again. X to the 10th minus y squared. So still looks very similar to what we just did. That middle term is missing. So we have to think what times itself would give me x to the 10. And so that would be x to the 5th times x to the 5th. Because remember, when we had something like this, that meant that we added those exponents. And so we got x to the 10th power. And then y squared is y times y. And we make 1 plus and 1 minus. And there's our answer. Last example. Factor 4n squared plus 28n plus 49. This one looks like our traditional trinomial that we would get after foiling. However, sometimes we want to look at these, and instead of just trying numbers, we can think, oh, maybe this is a special factor where I would have the same thing times itself. So I look at the first term, and it's 4, and so we think, does 4 have something times itself? The answer is yes, 2 times 2. And we look at the last number, 49, and in 49 we say, is there a number times itself? And we say yes, it's 7 and 7. So let's take a look. We have 4n 2n times 2n, and 7 times 7. Now notice these are pluses, so we are going to keep those additions. And then let's see if we're correct. So notice it's the same binomial twice. 2n plus 7 times 2n plus 7. Do we get that middle term? So we have 2n times 7, and then we have 7 times 2n. We get 14n plus 14n gives us 28n. So sometimes we get the same binomial exactly times itself. Another way that you might see this answer is 2n plus 7 quantity squared. So either way is correct. That's it for this video. As you work through your lesson, if you have any questions, be sure to ask your teacher. Have a great day.